Hello students, in the last video we have seen about the memory representation and the memory hierarchy, like how actually the memory is placed according to the cost and speed as well as the size in a hierarchical form. So let us see a little in detail like how it is or what are the things that these memory actually consist of. So memory hierarchy has a top one as internal processor memory that we have seen, right? So what does this internal processor memory mean? So this is the memory that is placed within a CPU or it is attached to a special fast bus. So it usually includes the cache memory and special registers, and it is again for the temporary storage, that is once the power goes off everything will be erased. So it is the fastest among all the memories that are available. Internal processor we have seen, because so it is on the top in the memory hierarchy, right? So why is it actually it is necessary? That is, it bridges the gap between the primary memory and the processor. So you might know, or we know, in the second level we have the primary memory as the fastest, right, and the smallest memory and the speedest. So why are we having this, like, as I told you, the bridge gap between primary memory and the processor? Because the internal processor memory works in a very high speed, and even the primary memory cannot cope up with its speed. So there has to be something that actually match these two speed. That is, something that is working on the internal processor memory should be able to communicate with the primary memory. So that is why we have this internal processor memory. That is, anything to talk, like, it's like, you want to talk to a processor but you don't have anything to talk to it. So in that situation comes this internal processor memory. So that acts as a bridge between the primary memory and the processor. Next we have the primary memory. So primary memory consists of two things, that is RAM and ROM. So what does this RAM do? RAM is nothing but, okay, the full form is random access memory. So what does this random access memory do? So it has, or it can be also called as a primary memory is also called as a main memory, and it has a RAM is the place where the computer temporarily stores the operating system, okay, and the programs and the current data, and it's volatile. So those who have taken computer science in the PUC might know. So what do you mean by volatile? Current data, programs, temporary OS, etc. But if you do not know, so what is it actually? See, when we say it is a random access memory, you have to remember one thing, that is the difference between the random access memory and the read only memory. So when we say it is a read only memory, you can say, or just remember that whenever it is possible or whenever you feel like reading from the memory, you can read it from the memory. That is why it is read only memory. That is, whatever is in the memory, just read it. You can just think of it like that, okay? Whereas RAM is a random access memory. That is, whatever is available to you, you just randomly grab it. You can just think of it that way, okay? So that is RAM. So what happens once, when there is an operating system and the system has been on, what has to be happened is this operating system should come to a place where it could be accessed, right? See, just a set of programs don't do anything, just a set of instructions or just a code doesn't do anything. That code has to be run into a program to run, right? So what happens, the OS that is actually present, just you can say it as a code, is converted into program in the RAM, and it stays there as long as your system is on. It is there. Okay. And the current programs, for example, you are working on something, it could be anything you're working. So whatever at present you're working on the system, that is stored in RAM. And once when the system is when you have finished your work and you press a save button or you come out of the application, whatever was been working in the system just goes out of RAM. That is, it is volatile. It also stays good as a, even if there is a sudden power cut or a power breakdown for your system, then again the information stored in RAM will be erased. Okay, so that is why we call it as volatile, or you can just simply say it as a temporary. That is, nothing lasts in this RAM. Then what is ROM? As I told you, read only memory, in the sense whatever it is there in ROM, it could be read anytime. That is, even when the power goes off and you switch on it again, then even then you have this information in the ROM. So then why is it necessary to have a ROM? It's necessary because the boot firmware BIOS is here. That is, initially when the system is just turned on, your CPU must take control of the whole system. For, for that, you should have an operating system, and that operating system will be loaded from ROM and will be stored in the RAM as a temporary OS. So that is boot firmware BIOS. Okay. Next, again, this is non-volatile, as I told you. See, even once you off the system, or if the power suddenly goes off and your system is off, what can be done? Even if you switch on after some time, if you switch on the system, the OS will be there, is it not? The OS won't be deleted in this, it will be there. You can on the system once again, but whatever you are currently working on the system will be lost. Nowadays we have, at least around half a minute earlier or 1 minute earlier, whatever you have stored, that is temporary stored, that facility is given by the system, and you can, give the action if you want to restore it or you want to replace it, whatever it is, or you want to make edit corrections to that file itself, that is done. But exactly at that point of time, what we were, when the system went off and you were working, that some of the data will not be available. So that is about primary memory. Next is the secondary memory. Secondary memory is nothing but what you have as a hard disk, floppy disk, pen drive, whatever it is there, it is the secondary memory. Why is it a secondary memory? Okay, it's also called as auxiliary memory. Then why is it a secondary memory? Because it is not as speed in working as a primary memory, and it is actually used as a storage backup. That is, whatever you are working and you want to save it for tomorrow, you just save in the secondary memory. And mainly the examples of this are magnetic disks and magnetic tapes. This is nothing but actually the hard disk drives that you are having, and also there were magnetic tapes used before, so that is also can be called as a secondary memory. And nowadays this magnetic tapes and disks are replaced by, compact disk, digital versatile disk, all these things, so DVD, CDs, and even pen drive. So these are have replaced these things, and but still we have this hard disk which has a magnetic disk in it. So that is about the secondary memory we have in the system. Next, let us see a little in detail about random access memory. Okay, so what happens first, this is your hard drive. Okay, that you can what happens is that data is and instructions is loaded into the main memory. That is, whatever the information you have stored, like yesterday or day before yesterday, that is actually stored in this random access memory. That is stored in the main memory. And what happens, that goes to the, that is loaded into the main memory. Sorry, I mean to say, from the hard disk it is loaded into the main memory. And in next, what happens, the data and instructions brought to the CPU for further processing. That is, once it is loaded into the main memory, I told you main memory cannot work that way. Anything that work has to be taken in the processor. So data whatever is in the main memory or the primary memory is brought into the processor. From the processor, what happens, processor gives the instructions, like the CPU instructs the hard disk to load the data and instructions from it to the primary memory. Okay, this it goes on. So this is how a random access memory actually works, or the communication between the hard disk processor and the main memory. Next is types of RAM. In RAM we have only two types, like as far as we are concerned, that is static RAM and the dynamic RAM. So obviously when there are two things, you must feel there must be some differences, right? So what does the static RAM do? It's it's a static till the power goes off. Static means, you understand, it is something constant, or it's there. Okay, it doesn't vanish, or it's not volatile or so. So that is static till the power goes off. And once the power goes off, what happens, it becomes a volatile memory. That is, something that is stored in SRAM is gets deleted as soon as the power goes off, as soon as the static RAM is not receiving any kind of power. Okay, or any kind of voltage or the electricity, whatever it is, when it's not getting, it will be erased. It is fast. Okay, compared to your dynamic RAM, it is fast. But as you know, as it is speed increases, the cost also increases, so that is why it is expensive too. Then what could be a dynamic RAM, or why that name dynamic? Dynamic is named because this needs a continuous refresh. That is, around 100 times per second it has to be refreshed. Refresh in the sense, what it is, you need to, give the data hundreds of time in 1 second. It's like, remembering. We remember you, others, or whatever, like we keep saying to the people, right? See, do this, do this, do this, every time we are remembering. Same thing here. What happens, you should actually should make a continuous refresh, so that whatever the data is there to be stored in the dynamic RAM, it is stored in the dynamic RAM. So it's very unstable. Okay, that is why you need to refresh, and always give the instructions for for around 100 times per second it should be refreshed. So for this refreshing thing, we need the uh, reset circuit is added to this dynamic RAM. In this dynamic RAM, a reset circuit is added. It is very inexpensive and small compared to your static RAM. So everything has its own usages. So static RAM is used as a cache memory because it's of very high speed, and whereas dynamic RAM cannot do this. But because of its low cost, it can be used where static RAM is not that necessary. In that things, we can use this dynamic RAM. So we'll see about read-only memory in the next video. Thank you.